Hello everyone, welcome once again. In our previous sessions, you would have noticed that we have been visualizing the data using various graphical methods. We have understood some of the important, widely used, very famous methods like histogram, box plot, scatter diagram. There is one very important and very widely used and very effective method to graphically understand the data or to visualize the data that we have gathered. Is used very widely in the industry. This method is called Pareto Chart, as you can see on the screen here. So I'll give you a little background about what Pareto does. As you all will be aware of a method called as 80-20 principle. 80-20 principle, what happens is that 20% of the data is responsible for 80% of the output. In an organization, 20% of the people who bring the 80% of the revenue, or you can say in a process 80% of the problems are caused by 20% of the reasons. So that's how this 80-20 principle works in. That there is always a small part of a process that's responsible for maximum output. If you correct that particular, if you identify and then correct that particular area, you are able to solve almost 70 to 80% of the process. So that's what Pareto diagram helps us. It helps us to prioritize the area where we need to focus. What are those 80%? It tells us, and also tells us to narrow down the scope what we are looking at. I'll give you an example before I jump to the Pareto chart and give you the example of the Pareto as a technical tool, but let me give you an example. In one of my assignments as a consulting assignment long back, we had a client who was having this issue of not getting the IT equipments on time. IT equipments can be laptop charger, monitor, mouse, keyboard. There are IT equipments. A company does not procure them on their own. They always buy it from a vendor. There is a vendor, they procure, it's called procurement. They have multiple vendors. Each vendor provides them these IT equipments in different capacity, and these vendors may be scattered across different locations across the globe. So this company was facing the issue of not getting the IT equipments on time. Because of this, the problems were the people who were joining the organization, they were not getting a laptop or a monitor or a keypad or a mouse on time. So because of this, the issues were the people were not able to do their job, they were not able to start their work. It was resulting in productivity loss, ultimately the revenue loss for the organization. And those who are in the company, they were not able to replace their IT equipments like a headset, like a laptop, like a monitor or a keyboard. So this was resulting into a lot of delay and also productivity and the revenue loss. Company was very concerned about it. They hired us as consultant and we started working on it. This is one of the largest IT companies in India. This company has 4 offices in India, 4 big campuses in India. Now we had to solve this issue and we cannot focus on all these 4 locations at the same time. So what we did, we first tried to understand what is on which location we have the maximum IT equipments procured. So we prioritized it and we realized Noida is one of the locations where they have the maximum IT equipments getting procured because they had the largest employee base there. In that location, we identified where there are around 22 different departments which are procuring or which are purchasing IT equipments. So out of this 22, we again prioritized. We identified there are only 5 to 6 departments which are responsible for 80% of the IT equipments. That means these 5 to 6 departments order 80% of total IT equipment which are ordered from that location itself. So in the entire Noida location, in the entire Noida office, these 6 departments are responsible for 80% of the total orders. Now in these 6 departments, now there were around 30 plus IT equipments which are ordered, different. It can be motherboard also. So out of the 30 equipments in these 6 departments, there are only 7 top IT equipments which are ordered maximum time, or the most number of time they are ordered. So you see what we are doing. We are narrowing down our approach from 4 locations to we came to 1 location. In that 1 location, we narrowed down to 6 departments out of 22. Then in those 6 departments, we narrowed down to 7 IT equipments out of 30. That's how we have narrowed down our approach and that area we identified to work upon. We worked in this small area, and the results that we got from this area, we replicated a lot of these results to other parts of the organization, because the results that we got from this project, they were very common to other parts also, because the improvement in vendor management, improvement our own process, like how do we procure, how do we approve the budgets, approve an invoice from a vendor. So all these things were solved at one area and they were replicated in the other parts of the organization. That is how we typically do a project. We do not look at the entire project as a whole and try to solve it. We can't chew more than our capacity. So now, how did we do this? This is where Pareto as a principle came very handy. So if you see on the screen, you will see we have a data set which talks about there are certain defects type. It says defect type are system return. Another type of defect type is miscellaneous. So and then another type of defect is stop payment. Another type of defect is supplier refund. So these are the 4 types of defects we have. If we have to figure out which is the biggest defect type out of these 4, which one should we focus? So we put that into a Pareto chart format. In the Pareto chart, you will see it actually like a bar. There are different bars of different defects type. Each defect type comes as a bar. The height of the bar represents the total value, the count in that one. So, and these bars are always in a descending manner. That means you will have the largest and the biggest bar first, then the second biggest, then third biggest, and so on. And at the tail, you have the smallest number. So you can see the first bar here that you are seeing here, which is about the stop payment. In that bar you can see below the stop payment it is written 431. 431 are total count of stop payment type of defect. Then system return 293 total volume of stop system return type of defect. Supply refund type of we have 120 defects, and miscellaneous we have around 9.3 defects. So these are the total values which is being represented by the size of the bar. Now below the number, now if you see the stop payment, below 431 it is written 46.0. If I add all number of defects, in the all number of defects, only stop payment is responsible for 46% of defect. This is the largest defect type. System return is responsible for 31.3% defects. Supply refund is responsible for 12.8% defects. And miscellaneous items are responsible for 9.9% of defect. Now let's go back to the first bar again. Stop payment, total count is 431, percent is 46. Now cumulative percentage. So stop payments as just one only bar is responsible for 46%. But if you add the system return defect also together, stop payment and system defect together are responsible for 77.3% defects. So out of these 4, if the first 2, the stop payment and system return, are responsible for 77.3% of total defects in the process. That is how we try to prioritize. We see the cumulative percentage which is the last line here. Now we had just 4 items here. It was easy to look at it. But what if you have 30 or 300 items, types of defects? In that situation, by looking at it will not be possible. You may have to prioritize and how much is 80%, how much is 20%. You can always calculate, but then it's a visualization. Calculation we have already done. The standard deviation, mean, mode, median, they were all calculations. We are putting that calculation into a graphical format for us to understand better. That's why Pareto really helps us to visualize what we are seeing here. So that's it about the visualization methods. What we have seen so far is a histogram. It tells us the distribution of the process, the central tendency, the variation, and the shape. And we talked about the scatter plot, which talks about the relationship between an x and a y, the independent variable and dependent variable. We then talked about the box plot. It divides the data into 5 different elements: the minimum data point, the first quartile, median, third quartile, and the maximum data point. And it tells how the data is spread from minimum to the maximum data points into 4 quartiles, how much data is in which quartile. Then we talked about the Pareto chart, which talks about the 80-20 principle. that how many causes are or how many defect types are responsible for almost 80% of the total issues in the process. That's where Pareto chart comes in. So these four visualization methods are very commonly used, widely used, very effective methods to visualize the overall data that we have just gathered, that we understood from the sampling and data collection plan. So this is about the graphical techniques of the data that has been collected. Thank you for watching. This is Shivendra Sharma.